Hello guys, it's Kamil. I would like to talk about data types in this video. I know I've mentioned I may be talking about functions, but actually in the Rust book the data types comes first, so I think that'd be actually worth to go over them. So actually we could create a new thing called data types. I don't know if we'll use it actually, so maybe we will not create it. But Rust is a strongly typed language, which means that we need to provide a data type for our variables and other things as well at the compile time, so that there are no surprises and the compiler knows what to do, how to treat things. Some situations, compiler can just infer the data type for us, as we have talked in the previous videos, I believe. As you can see, this example I may have been talking about, that if you have some string and you will parse it into a value, into a number, then Rust will not know what exactly you expect. So you need to tell it explicitly, otherwise it will raise you some, or it will throw you some error, right? The compile time error. And it even tells you consider giving as a type. We'll talk on this video, we'll maybe talk about integers because they're quite long, and then maybe in the other videos we'll try to address other data types. So integers are like, well, one of the scalar types in Rust, one of the primitive scalar types, which are four. There are four of them, and we'll go over the first one. The four types actually that there are is integer, float, bool, and char. There are also compound types that we'll talk over in another video as well. So now, integer types are like it's like numeric values with no fractional part to them. And in Rust, you have a couple types of them. You will have signed and unsigned. And the signed means that it can have a negative value, it can negative sign to them. Unsigned can only be positive. And let's look at various data types that we have inside of the table. So they will be divided by a length, let's say, and also whether signed or unsigned, whether they are signed or unsigned. If you can look at this table, then you'll have I8, U8, I16, U16, and further up to 128. And then you'll have one that is kind of a little bit different than the others, I-sized and U-size. And actually this one is normally used for like accessing indexes in the array, or it will also be used for the length of your string, let's say. And actually, if you'd like to know what will be the size of it, then you need to look at your architecture of your operating system. So for 32 bits, it will be 32 bits long. If it's 64 bits that you roll, it will be 64 bits. Probably you are on a 64 bits architecture in these days. Okay, so now let's also talk about how you can find what is the lowest and the maximum value of specific size. So if you have this U8, or sorry, yeah, let's start with a U8 type, which we know is only positive. And I know that 2 raised to the 8th power is 256, so we must have 256 values there. The way you can calculate the highest and the highest value is just raise a 2 to the nth power. So raise 2 to the 8th, which I told you already is 256. But because we have to account for 0, then we will do -1 and we'll get 0 to 255. Now, if you would like to calculate the assigned one, it's a bit more involved because you have a couple of sides. And Rust is using two complements for specifying the signed integers. As just something to mention, I will not be going over how that works in this video. But if you actually will try to calculate that, you can do it by simply first doing the lower bound, and that will be again 2 raised to the nth power minus 1 this time. So it will be if it's 8, then it will be 2 to the 7th, and 2 to the 7th, you can trust me, is 128. And then you need to make it negative, so it's minus 128. And then if you look at the positive boundary, then it will be 2 raised to the nth power minus 1. So that will be 2 raised to the 7th, which is 128. And you need to still account for 0. So you decrement 1, and you will have 127. So the range will be like here, minus 128 to 127 with a 0, which gives you 256 values that 8 bits can store, and no more, right? Now, in Rust, what you can do with integers, you can actually use underscores to separate numbers. And that is very useful in large numbers. Like if you, for example, have like billion, and you know billion has like 9 zeros, it may be harder for you to read. You may think, oh, it's maybe 10 million, uh, or whatever, or or 100 million. If it's 1 billion, then what you can do, you can actually you can use underscores like this, and this will separate 0 nicely for you. It will be much easier for you to read things. Now, other things that you can do apart from decimals in Rust are hexadecimals, octals, and binary, and even byte. Now, the hexadecimal you can specify using 0x, provide then 0 to 9 or A to F, which is how you specify, or how you actually type the hexadecimal anyway. Octal you can do 0, and 77, which are values from 0, 7 for each of them. And for example, where you can find octals are in Linux permissions. The binary, you do 0b and then provide 0 or 1s. And as you can see, you can still use underscores. And there's also a byte. And for byte, I think you can use an ASCII value. So you type B, single quotes, and then some ASCII like uppercase A, which in fact is a number 65, which you can check in the table here. So in here 65 is A, right? And uppercase A, so that be the numerical value you will get for that, for example. Now, if it comes to integers as well, actually, then whenever you define an integer and you don't annotate it specifically, the Rust itself or the compiler will select I32 for you. Of course, if it will be inside of this range, right? That's what Rust will do by default. And now there's another thing with integers as well, is integer overflow. And that is handled in a way, or maybe what it is. It means that, for example, if you have a specific size, so let's say U8, and that U8 has a boundary, the bottom is 0 and the high boundary is 255. If you try to cross the boundary, what will happen, right? This is the integer overflow. So the way Rust handles it the Rust handles it in a couple of ways. One, if you're in debug mode, it will actually throw you a runtime panic and will not allow you to carry on. If you are actually in the release mode, then what Rust will do for you, Rust will simply wrap it. So if you are at the top boundary, it will wrap to the bottom. If you are at the bottom, it will wrap to the top. So if you are at 255 and you want to go to 256, you will go back down to 0. If you're at 0 and you want to go to -1, you'll go back to 255. That's how this will go. And actually, this relying on this is considered an error, so please don't do it. However, there is a way that you can actually enforce the behavior to work the same across different compiler types. And it's mentioned in this grayed out box, and I'll support myself with this now. So if you look at the actually wrapping, if you'd like to use wrap in almost, you can use wrapping methods because there's a set of methods you can use, such as wrapping add. You have also, if you'd like to return a none in case if there is an overflow, then you can use a checked method. if you would like to return the value and the boolean will specify whether there was an overflow or not. Then you can use overflowing method. If you would like to saturate at the values minimum or maximum, so saturate at the values minimum or maximum values with saturating method. You can use that too, in case that is something you want. So that would be integers. I think I will end the video at this moment because it's already taking some time. And I will meet you in the next one when we can finish off our scalar types. Bye bye. Thank you a lot for your listening.